Hello, welcome back to Introduction to Exponential Rules Part 2. In this video, we're going to be breaking down our original algebra table for y is equal to 2 to the power of x. We're going to be looking at exactly what it means, and then we're going to be looking at what the rule of the exponential graph will look like. On the left here, you can see an expanded version of our original algebra table. When we have a rule such as y is equal to 2 to the power of x, it means that when x is equal to 1 here, y is equal to 2 to the power of 1. When x is equal to 2, y is 2 to the power of 2. When x is equal to 3, y is 2 to the power of 3. When x is 4, we have 2 to the power of 4. When x is 5, we have 2 to the power of 5. We'll start with 2 to the power of 2. Most of us know what 2 squared means. 2 squared means that we have 2 times 2. 2 multiplied by itself twice. And we know our answer is equal to 4. If we go back to 2 to the power of 1, this means that 2 is there on its own, one value of 2. So our answer is 2, both in expanded form and as a numerical answer. 2 to the power of 3 is 2 times 2 times 2. 2 multiplied by itself 3 times. 2 times 2 is 4. 4 times 2 is 8. 2 to the power of 4 is 2 times 2 times 2 times 2. 2 multiplied by itself 4 times. 2 times 2 is 4. 4 twos are 8. 8 twos are 16. And lastly, 2 to the power of 5 is 2 multiplied by itself 5 times. So we have 2 times 2 times 2 times 2 times 2. 2 twos are 4, 4 twos are 8, 8 twos are 16, and 16 twos are 32. So now we have the answers that we had in our original algebra table. And we can see that, again, as we go down the table, our y values are doubling. Well, what does the graph of this exponential rule look like? If we plot our graph on our Cartesian plane that we have here on the right, we will see when we have x is equal to 1, we know that y is equal to 2. If we look at our scale on our graph, we can see that on our x-axis, we've got a scale of 1. On our y-axis, we've got a scale of 8. However, we can see that this value here is 4, 8, 12, 16, 20, 24, 28, and 32. So when we plot our first point, when x is equal to 1 and y is equal to 2, the point will go approximately here, halfway between 0 and 4. When x is 2 and y is 4, it will go here. When x is 3 and y is 8, it will go here. When x is 4 and y is 16, it will go here. When x is 5 and y is 32, it goes up here. Now, if we look at the pattern in the points, we can see that it definitely isn't a linear rule. It's a nonlinear rule because we can see that the points seem to be following a curved pattern. If I join my points together and I try and do it as carefully as I can, we can see a curve developing there. We can see that the curve is an increasing curve, and we can see that as we look at the graph horizontally this way, that the graph is getting steeper and steeper. All exponential curves follow this pattern. They're increasing curves and they get steeper as you move to the left. I hope that this has given you a good introduction to exponential rules, what the patterns look like and what the graphs look like. Thanks for watching.